Hello guys, today we are gonna talk about how to model the DC direct current motor in system dynamic perspective and how we do use this modeling technique in simulation programs like the Matlab. Okay, and so this is our headset related to the DC motor application via system dynamic modeling. Okay, and so in order to do that, we should define the introduction or index of our lesson. And so in order to cover the full picture of the DC motor application via system dynamic modeling, which means that the time response of this system dynamic, and we should create a subset of this lesson. Okay, and so firstly we should learn about how do we use or how to define the analogy modeling, okay, in this study, which means that this emulation or representation of all kinds of dynamics in universe. We can utilize the analogy models to create a system dynamic perspective of the model. And so if we learn these things, and then we can create our specific model, especially in the DC motor application or the mass spring damper or the any identified mechanical or fluid or electrical system in universe. Okay, and so this is a mathematical technique, but behind a philosophy we should get this into to drive or the model this DC motor application. Okay, and so if we have learned this, and then we should pass or we should forward to basic physical parameters or constants section, because we need to create or we need to calculate the basic physical parameters like the inertia or damping ratio or spin coefficient or resistance of electricity or inductance or the electricity values, because this parameter identify the whole system model in maths. And then we should create or we should define these things in order to emulate or simulate this system dynamic model. In this course we should focus on only the DC motor application, but we have this pattern in every mechanical or fluid or electrical system. Okay, and so in order to cover or understand the underlying mechanism of these two things, we should learn how to use the energy forms patterns. Okay, and so these constants or coefficients or parameters directly relate to the kinetic energy or potential energy of this system. And so in order to emulate or simulate these things, and then we should define to translation or the conversion of these two things. Kinetic energy is converted into potential energy, and then we have a dynamic in time or with respect to the time. Okay, and so if we cover the whole things, and then we should focus on the calculation of the physical parameter in the next session. Physical parameters. Okay, but in real life application, real life means that there are two consequences of the parameters that needs to be calculated in this study. And former is the shape parameter or dimensionality of this system dynamic model, and then the second or the latter is the selection of the material property either the mechanical system or the electrical system. Okay, and so if we get this calculation technique, and then we should focus on the dynamic equation or equation of motion. Okay, this is our study of the theoretical part of this lesson, and then we should focus on how to simulate in a one simple basic programming language. In this lesson, we generally use the Matlab Simulink block. But in dynamic equation form, we should create a transfer function model, state space representation, and even the nonlinear models can be added by using this Matlab Simulink toolbox. Okay, and so in a script form, we own our dynamic modeling approach in this session. And so we write a code with a for and if and simple syntax of the programming language, and then we can analyze all the things in practical forms. This is our main aim of this study. And then if you end or if you finish this study or the lesson, and then you will get a detailed information how to model DC motor application in STEM dynamic modeling, and then how you learn about how to model this dynamic and get result by using the Matlab Simulink application.